Hello, my name is Hassan Noorvand. I am from Department of Construction Management and I am going to give a presentation about sustainable development of rice husk ash cement based composite with nanotitanium. Okay, let's start with the table of content. The presentation starts with research background and problem statement, and then it goes to the objective, literature review, research methodology, result and discussion, conclusions, and it will be finished by future study. First, I want to talk about research background. Green concrete is environmentally friendly material and sometimes is called sustainable concrete. One way to develop a sustainable concrete is to replace cement with supplementary cementitious materials or mineral admixture, which is a common practice in production of concrete industry. The origin of these materials are agricultural and industrial byproduct. The function is to improve in concrete properties as well as reduction in cement content. And there are many types of mineral admixtures. That common types of mineral admixture are silica fume, fly ash, GGBS, metakaolin, and rice husk ash. During the thrashing process of paddy, which comes from the field, husk is obtained as a byproduct. For each tons of paddy milled, 202 kg of husk is produced. Generally, husk is about 22% of the dry mass of harvested paddy, which presented a disposal and landfill problem for rice mills, and since they are bulky. As a solution to the problem, husk is used as a fuel for power generation or in the boiler for processing of paddy. The ash formed during this process is called rice husk ash. So in order for rice husk ash, which in this study called black rice husk ash, BRHA, to be used as a cement replacement, they need to be treated by burning, chemical treatment, and grinding. However, these processes are a challenging process and they're costly, so they are disposed in special hazardous waste landfill and finally leads to polluting water resources and environment. So the objective of this study can be categorized as: first, to enhance the mechanical properties of black rice husk ash cement mixture with the addition of nanotitanium by compressive strength test. And the second objective is to determine the microstructure of black rice husk ash cement mixture with different percentage of nanotitanium by SEM test. According to the literature review, nanomaterial can improve the properties of concrete by first acting as filler effect, which increase the density of the matrix by reducing the pore volume. Secondly, they accelerate the hydration process at early ages. And finally, they act as a nuclei effect. The hydration product of concrete, which are CSH and CH, can be modified by addition of nanomaterials. This is why mechanical properties of cement composite with nanotitanium was enhanced. For my methodology, I had a data collection. I did some pilot tests to get the sand gradation. Since the workability and flowability are constant for all mixes, I did some pilot tests to get the dosage of the superplasticizer for each mix design. Then I started my actual mix design. As you can see, I had control sample, which here it is shown as CO, and we have 10, 20, 30% of black rice husk ash. For the cement replacement, R10, R20 and R30 stand for different percentage of black rice husk ash. Different percentage of nanotitanium, which are 0.1, 0.51 and 1.5 were used for each black rice husk ash samples. According to the ASCM standards, the SP or superplasticizer percentage was adjusted. Dry mix method was used, and water sand cement ratio for the whole sample is 0.35, 2.75 and 1. For the second part of the methodology, I'm going to explain the tests to meet the first objective, which is mechanical properties of control. Mechanical properties of concrete. I use compressive strength test, and the macrostructural test was conducted by FEM in order to meet the second objective. So the result for compressive strength is drawn in a table. As you can see from the table, control sample has a compressive strength of 67.3 megapascal, and after replacing 10% black rice husk ash, the strength decreased to 64 megapascal, or it shows 5% reduction in improvement. However, addition of nanotitanium showed improvement in all samples. The biggest improvement, which is 13%, occurred in 1.5% of utilizing nanotitanium. Even addition of 1% nanotitanium in 20% black rice husk ash replacement shows higher compressive strength in comparison to control sample. Finally, although using nanotitanium with 30% black rice husk ash replacement has shown improvement in strength to compare with black rice husk ash alone, the compressive strength is lower than that of control sample. For the second part of the result, which meet the second objectives, I conducted the ACM test. As you can see from figure A, which is only black rice husk ash sample, the matrix has a porosity structure, while incorporating of nanotitanium, which can be in figure B, showed improvement in the density of the specimens. So, using nanotitanium resulted in improvement in density of the specimens. In conclusion, the results have shown that addition of nanotitanium modified physical and macrostructural properties of black rice husk ash, and the first objective was achieved, and 1.5% nanotitanium with 10% black rice husk ash in cement showed the highest value for compressive strength. 18% improvement was observed in compressive strengths of black rice husk ash mortar with admixing 1.5% nanotitanium at the 28 days. Addition of 1.5% nanotitanium increased the replacement level of black rice husk ash up to 20% with comparable compressive strength to control sample, and the results indicate using nanotitanium enhanced the microstructure of black rice husk ash mortar by accelerating the hydration process, nucleations, as well as filling effect. Also, the interfacial transition zone or ITZ and density microstructure of black rice husk ash was improved significantly in the presence of nanotitanium, which these two improvements meet the second objective. For the future study, we can study the production of high-performance concrete with treated rice husk ash and nanotitanium, and the differences between low and high concentration of nanotitanium can be studied. And finally, nanotitanium can be studied with other waste materials as well. And these are the references that I have used for this presentation. With this, I end my presentation, and thank you.